All right, let's dive right into one of the most mind-bending frontiers in tech today, the absolute revolution happening in brain-computer interfaces. We're talking about technology you can actually wear that can understand your thoughts. And the engine making it all possible, you guessed it, artificial intelligence.
Just think about this quote for a second. An MIT researcher is saying that this tech could soon be as common as unlocking your phone with your fingerprint. I mean, that's a massive shift, right? We're seeing something go from a niche, high-tech science experiment straight into our everyday lives.
So that's the billion-dollar question, isn't it? It sounds like something straight out of a movie. How on earth can a headset or even a pair of earbuds translate what's happening inside your brain into a command for a computer? Well, that's exactly what we're going to break down, how this is happening right here, right now.
Okay, let's get one thing straight. When we say mind control, we are not talking about surgical implants. The real revolution is happening with non-invasive tech. We're talking about devices you can put on and, just as importantly, devices you can take off. And that is the key that unlocks this for all of us.
So what even is a BCI? You can think of it as a translator. It's a system that listens to all that electrical chatter happening in your brain, figures out your intention, like, I want to move that cursor to the left, and then turns it into a digital command that your phone or computer can understand, all without you having to lift a single finger.
Now, if you're going to decode thoughts, you first have to be able to listen to them. And that means tapping into the brain's natural electricity, that constant hum from billions of neurons firing away. But as you're about to see, listening in, well, it's not quite as simple as it sounds.
Here's the fundamental problem, and it's a big one. Your brain's electrical signals are incredibly faint. By the time they pass through your scalp, skull, and all that tissue, they get mixed in with a ton of other noise. It really is like trying to hear someone whisper from across the street during rush hour traffic. For decades, this signal-to-noise problem was the biggest wall we just couldn't get over.
So how do we even try to listen in? Well, there are a few different methods. EEG is the one you see most often. It's fast, it's portable, and it's pretty affordable because it listens for those direct electrical signals. Then you've got something called FNIRS, which is a bit slower because it uses light to track blood flow changes, which is a good proxy for brain activity. And now we're seeing some really cutting-edge stuff like OPM-MEG, which uses tiny quantum sensors to pick up the brain's magnetic fields with amazing precision. Each one has its pros and cons.
And you know, the hardware itself has gone through a crazy evolution. We've gone from these bulky, wired caps that needed you to slather goopy, conductive gel all over your head to these sleek, dry sensors made from advanced stuff like graphene. And the form factor? It has shrunk from a science experiment on your head to something as discreet as earbuds or a simple headband you could wear anywhere. That right there is what's making consumer BCIs a reality.
But here's the thing. Better hardware is only half the battle. You can have the best microphone in the world, but if you don't understand the language being spoken, it's useless. That is where AI comes in. It is the universal translator for our brain's incredibly complex electrical language.
Let's break down how this actually works. First, those dry sensors pick up the raw, messy brainwaves. Then, and this is the magic part, this is how we solve that signal-to-noise problem, that messy data gets fed into a deep learning model. AI algorithms, like what are called convolutional neural networks, are just brilliant at sifting through all that noise to find the hidden, meaningful patterns. And finally, the AI classifies that pattern, decodes what you intended to do, and sends out the command.
And just how good is AI at this whole translation thing? Well, in some studies, researchers have hit a staggering 96.75% accuracy in classifying these signals. Just let that sink in. That is a near-perfect translation of a thought into a command. This is the breakthrough that's making everything else we're talking about possible.
Okay, so we've got the hardware, we've got the AI translator. Now for the really exciting part. What can we do with all this? The application's pretty much split into two incredible categories: healing people and enhancing our everyday abilities.
On the healing side, the impact is just profound. For a stroke patient, a BCI can link their intention to move with an exoskeleton, creating this powerful feedback loop that actually helps rewire their brain. For people with paralysis from something like ALS, it's giving them a voice, letting them communicate at over 40 words per minute. It's literally giving people back pieces of their life that were taken away.
And then you've got enhancement. Imagine playing a video game that gets easier or harder based on your frustration or focus level. Or picture this: headphones that can tell you when you're in a deep state of flow so you know not to break your concentration. We're already seeing this stuff used to fly drones and to control augmented reality glasses. It's all about making our interactions with technology totally seamless and intuitive. So, where is all this headed? Look, this isn't some far-off technology that's 10 or 20 years away. The real inflection point is happening as we speak, and the market for it is growing at an incredible pace.
I mean, just look at this timeline. Right now, this year is when the funding is really starting to shift towards consumer gadgets. By next year, you're going to see these discrete hearable devices become way more common. And the forecast for the market is just explosive. The big transition from the science lab to your living room is happening now.
And that brings us to the final and maybe the most important question of all. This technology has unbelievable promise to heal us and to enhance our lives. But as we get better and better at decoding the brain's signals, we're stepping into a totally new world of mental privacy. The question we all need to start asking ourselves is this: as we learn to read minds, what are the rules we need to write to protect them? And that's something to think about. Thanks for tuning in.